Hey everyone, welcome to our first lesson. This day we'll be talking about trigonometric ratios. We're going to discuss the definition, we'll have some examples, and of course some exercises. So before we proceed to our trigonometric ratios, it is very important to take note that we should recall first the concept on Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse is equal the sum of the squares of the two remaining sides. So example, if we have this triangle and the hypotenuse, that will be our C, and then the other leg is our A, and then the other leg will be our B. So in this right triangle, C squared is equal to A squared plus B squared. Again, C is the length of the hypotenuse, A and B are the length of the legs of the right triangle. So example, find A in the triangle shown. So for instance, we have this right triangle. The unknown side is A. We have the hypotenuse, which is 13, and the other side, which is 12. So to solve for A, we will be using the Pythagorean theorem, that is C squared is equal to A squared plus B squared. Substitute the values. So we have 13 for C and 12 for B. Simplify. 13 squared is 169. 12 squared is 144. To get the value of A squared, we just simply subtract 144 from both sides. So that will give us 169 minus 144 is equal to A squared plus 144 minus 144. And this will give us 25 is equal to A squared. Extract the square root. So the square root of 25, that will give us 5 units. Remember, we will disregard the negative value because we are dealing with measurements. We cannot have a negative value in our measurements. Take note of that one. So that's our Pythagorean theorem. Now I want us to consider this right triangle ABC. Remember again that this is our hypotenuse. The hypotenuse is always opposite the right angle. This will be our altitude or the height of our triangle, and this will be the base of our triangle. Now using the same illustration, with respect to angle A, this side will be the opposite side of angle A. This side will be the adjacent side of angle A, and of course that will be our hypotenuse. Now using again the same illustration, with respect to angle B, this side will be the opposite side of B, this side will be the adjacent side of angle B, and of course our hypotenuse. So I want us to remember the location of our opposite and adjacent side. So what are trigonometric ratios? So when we're talking about trigonometric ratios, these are the ratios of the sides of a right triangle. There are 6 trigonometric ratios. Namely, we have the sine, we have the cosine, the tangent, cosecant, the secant, and the cotangent. So sine is written as sin, cosine is cos, tangent is tan, cosecant is CSC, secant is written as sec, cotangent is written as cot. Now remember earlier we said that trigonometric ratios are the ratios of the side of the right triangle. So when we're talking about sine, basically we are getting the ratio of the opposite side of the angle and the hypotenuse side. So that is opposite over hypotenuse. That will give us SOH. SOH. Cosine is given by the adjacent side over the hypotenuse, or that will give us CAH. Tangent, on the other hand, we have the opposite over the adjacent side. That will give us TOA. Cosecant, we have the hypotenuse over the opposite side. That will give us CHO. Secant, hypotenuse over adjacent side, that will give us SHA. Cotangent will give us adjacent side over the opposite side, that will give us COW. So if you have a hard time remembering what is the ratio of sine of the angle, just remember these mnemonics. So katoa, cho, sha, cow. Again, that is so katoa, cho, sha, cow. O is for the opposite, H is for the hypotenuse, A is for the adjacent side. Sine, so, cosine, ka, tangent, toa, cosecant, cho, secant, sha, cotangent, cow. Again, that's Sokatoa, Josha, cow. Example 1. Find the 6 trigonometric ratios of angle A. So if this is our triangle ABC, so what are the 6 trig ratios of angle A? So we'll be using our mnemonics, Sokatawa, Cho, Shakao. So for sine of the angle A, we have the opposite over the hypotenuse. Now the opposite side of angle A is 3. The hypotenuse is 5. Therefore, we have 3 over 5. Cosine of angle A, we have the adjacent side and the hypotenuse side. Adjacent is 4. Hypotenuse is 5, so we have 4 over 5. Tangent of A, we have opposite over the adjacent side, so we have 3 over 4. Cosecant of A, hypotenuse over the opposite side. Hypotenuse is 5, opposite side is 3, so we have 5 over 3. Secant of A, hypotenuse over the adjacent. Hypotenuse is 5, adjacent is 4. So we have 4 over 5. Cotangent of A, adjacent over hypotenuse. Adjacent is 4, opposite is 3. So we will write 4 over 3. Let's have example 2. If you want to try this problem, you can simply pause this video and proceed after you're done answering. Find the 6 trigonometric ratios of angle B. So this will be our right triangle ABC. Hypotenuse is 17, the altitude is 15, the base is 8. So what are the 6 trigonometric ratios of angle B? We'll start with sine. Opposite over hypotenuse, 15 over 17. Cosine, adjacent over hypotenuse, 8 over 17. Tangent, opposite over adjacent, 15 over 8. Cosecant, hypotenuse over the opposite side, 17 over 15. Secant, hypotenuse over adjacent, 17 over 8. And the last one, the cotangent, we have adjacent over opposite, that will give us A over 15. Now let's proceed to example 3. So find the 6 trigonometric ratios of angle A. Now what if you are given this triangle? There is no value of our height. As you can see, we have the hypotenuse, which is the 25. We have the base, which is 7, and the value of B, the height of the triangle, is unknown. So how do we solve this problem? So earlier, we talked about the Pythagorean theorem. So we will be utilizing the Pythagorean theorem to help us solve this problem. Again, the Pythagorean theorem states that C squared is equal to A squared plus B squared. Our C is equal to 25, our A is 7, and we are looking for B. So we will write 25 squared is equal to 7 squared plus B squared. Simplify. 25 squared is 625 and 7 squared is 49. So we have 625 is equal to 49 plus B squared. Subtract 49 both sides. We will have 625 minus 49 is equal to 49 plus B squared minus 49. 625 minus 49 will give us 576. 49 minus 49 is 0, so what's left is B squared. Extract the square root of 576. So the square root of 576 will give us 24. Again, we will disregard the negative square root because we are dealing with measurements. So B is equal to 24. So if B is equal to 24, we can now solve for the 6 trigonometric ratios of angle A. We have the sides of the triangle, 25, 24, and 7. So sine A, opposite, hypotenuse, 7 over 25. Cosine of A, adjacent over hypotenuse, 24 over 25. Tangent of A, opposite over adjacent, 7 over 24. Cosecant of A, hypotenuse over the opposite, 25 over 7. Secant of A, hypotenuse over adjacent, 25 over 24. And the last one, cotangent of A, adjacent over opposite, is equal to 24 over 7. Now, if you have noticed, the values of cosecant, secant, and cotangent are just the reciprocal of our sine, cosine, and tangent. The value of sine is the reciprocal of cosecant. The value of cosine is the reciprocal of secant, and the value of tangent is the reciprocal of cotangent. So that's it for today. If you want to check your understanding about this lesson, click on the link provided in our description box for the short quiz. We'll see you in our next video.